Thanks everyone for joining me today. My name is Foo. I'm a lead technologist and security specialist at Thoughtworks. And today I'm going to speak about pipelines and security tooling. I'd like to start speaking about the landscape in the last 20 years. We had a dramatic change in the technology industry, in the software delivery industry, with the introduction of numerous practices, out of which I'd like to call out specifically continuous delivery. And all of this helped us deliver it at a much faster speed. We moved from big monolithic deployments happening not very frequently, once a year, every 6 months, to having more empowered, faster teams, inclusive of multidisciplinary, cross-functional, arriving to DevOps, including infrastructure operations in our practices, and accelerating all the time. At the same time, though, following data collected by Verizon's data breach investigation report, we can see that across the years there's been an upscale in the number of security breaches which cause was traced to a developer mistake or to an operational mistake. This led to some very high-profile breaches back in 2017. You might have heard about the Equifax incident. That was mostly caused by a Java dependency that contained known vulnerabilities that has not been patched for a long time. So this seems to go hand in hand, and the question is, does that mean that going faster makes us less secure, makes us more reckless? Should we stop going fast? Should we just slow down and rethink our approach? I kind of wanted to build a case for this and talk through it, but then, coincidence actually, while I was building this deck, I stumbled upon this book, Accelerate. This is the distillation of 4 years of the State of DevOps report by Puppet Labs. I wouldn't be building a case for this, I would just really recommend the book. The TLDR, the book presents how they identified via research a number of findings and correlation between what they call 24 key capabilities that organizations might or might not employ, and being able to have higher performance in the software delivery. In particular, the key finding that we'll take out of this is the quality and speed is not a trade-off. You can have both, and likewise is security. In this, one of the key capabilities they identify is, in fact, shifting security left. Or rather, if you're not familiar with the terminology, it would be taking something that usually is far down the chain in shipping our software to production, maybe just before releasing to production, having a big review, and bringing smaller, faster elements of this as early as possible in our life cycle, and trying to have a faster feedback cycle. So hopefully this is where we get as the next step, moving from DevOps practices to include security as well, and moving towards the DevSecOps world. At least that's one of the buzzwords that is associated with these practices these days. So going into the practice of this, what I want to share today is how we, in the last year, included some of these practices in our projects. And just show some practicalities of this and discuss challenges and how we solved some of the things. I'd like to start by some tooling that in an organization practices continuous integration and continuous delivery usually have. That is your CI server or CI pipeline. Whichever you might have, these are some: Go, Buildkite, Concourse, Travis. I was around thinking in terms of what we can do from a team that is maybe mostly developers, that doesn't have a background in being able to do vulnerability assessment. What can we do to identify and detect some risk and threats? Just looking around out there's a number of tools that are actually quite easy. Even if you don't have a lot of knowledge in the area, you can just pick them. Just following the how-to guide, you're able to get some results out of it. Of course, the story doesn't finish here. You just don't. It still requires some learning, but the barrier to entry is really, really low. Some of these are open source, like OWASP, GitLeaks, find set bugs. There require no licensing. There's no process of going and buying license or going through your departments for building. Some others might require licensing, but the key point is you can just download them, run them, and get something out of it. So the main thinking of this is, well, can we just maybe run these inside our software pipelines and get hook them into our feedback cycle that we already have? What I want to show is based on a case study of a project from last year. So I just want to name some technologies that we use in the context to add some color, if you wish, to the next few sections. And what we were building at the time was mainly based on Concur CI, so that's the CI tool that I will mostly refer to. It was mostly a Java-based Spring Boot application deployed and shipped as a Docker image. Included a front-end in React, JavaScript. Everything was deployed on Amazon Web Services, specifically on the ECS service. Little highlight on Concurs. I don't think is very common yet as a CI tool. The official documentation presents it less as a CI tool and a continuous things doer, in the sense that it tries to be. It doesn't really come with many features out of the box, but at the same time, it embeds this concept of externalizing every type of functionality that makes it really, really flexible, entirely based on tasks being Docker containers, with some looking into how to compose even sometimes basic functionality. You can really make it do anything. And we found that was really, really good, especially for making it do something that is not just building code, when you have to think a little bit out of the box from more traditional CI pipeline. We found it really good for infrastructure specifically. The concept here is quite intuitive in an already existing pipeline. And just we have our commits to source repository. Our CI server will have a suite of tests, build, integration test, UI test, or whatnot that is already being performed. We want to be able to say, right, now that I found some tooling that I might want to include in here, how do I get some fast feedback out of this? And the idea is we just add more tasks to our CI system, be that in serial with the existing build and test process, be that in parallel. But what we really want out of it is to say, well, can I, given the results of this tool, say save to continue or block the pipeline and make it so the team will be aware of this and look into this and fix it earlier. So yeah, the idea is simply add more stages that ultimately converge before deployment, be that a deployment to a pre-production environment or to a production environment. And connect the tooling so that it is able to fail, it's able to fail the pipeline, potentially, hopefully, if you have an information radiator, build monitor, create some big red box for someone to look at. I'm going to go more into the detail now of three tools that we used. One is Nick, one is Gitlix, and one is Spotbox. So first of all, I want to make a note of supply chain risks. I mentioned earlier the case of the Equifax breach caused by a vulnerable Java dependency. Supply chain risks is all the kind of risk and threats that are coming from the practice of having shared libraries, frameworks, or reusing code published by someone else. As part of our day-to-day job, of course, rewriting everything from scratch would be unthinkable. There's software solutions, practices that have been commoditized, so we can just pick them and use them. But it's not always as easy as saying, oh, cool, there's this cool new library out there, I'll just pick it and use it. There's a number of questions that both are not asked before selecting something. Like, what is this code actually doing? It's saying that it's doing A, but is it doing something else behind the scenes? Will I notice? Do I know? Does it contain no vulnerabilities? And this is often the case, especially on the open source world. It's possible to just review this code. And there's someone out there that might go around and look into that and say, oh, hey, this does look right, and I can maybe take advantage of this. Has the package been tampered with? It might as well be that where this is published, someone might try to even if the original package does not have any problem, someone might add something to it. Do we trust the authors? Does it seem like quality code? Are the authors malicious in the first place? And so on and so forth. And availability as well. That's why it's usually recommended to have an internal mirror of packages just in case stuff goes down or is removed. You might remember the case in the NPM registry of LeftPad. That was, I think, 3-4 years ago. When a package was being removed, a lot of stuff was based on it. The internet stopped working for a good day. Not fun. Now, in all of this, Snyk is a vulnerable dependency scanner. It doesn't address all of this, but it takes specifically on the question, does any of the packages that we're using in our software solution have known published vulnerabilities that will require patching, and how bad these vulnerabilities are. It's a product that originally started supporting NPM, then over the years they had the support for many other languages, including more recently Docker support, that I think was introduced 1 year ago. It also does a number of other things. It offers remediations, automatic pull requests, stuff, integration with your source code. I didn't personally use any of those features, especially for including this in the pipelines, but it does more than just this. So the question is, can we use this tool included in our pipeline? What is the formula to make a tool fit in the general concept that I showed earlier? For me, it's mostly 2 points, really. And the first one is, do we have a command that exits in a way that makes the build fail? Luckily, the tool is already written in a way that running Snyk test, if there's any findings, it will return an exit code. Will make our big red box to be very noticeable. And the second point is, are we able to limit the findings? And this seems counterintuitive because ideally, if you have 20 vulnerabilities, you want to find all of them. You don't want to find only 3 of them. But there's an important point that I want to make about what's called the phenomenon of red fatigue. You might be familiar with this already if in your pipeline you have a lot of flaky tests or something that depends on, let's say, an external service that has poor availability. And what happens is that your pipelines will often fail for some obscure reason. And it's hard to debug why. Or sometimes you know that you have to wait for half an hour for some service to come down, and over time you start being familiar with your build monitor being red and say, yeah, just fine, we'll be back in an hour or something. And what happens sometimes with security tooling specifically is, well, depending on the tool, false positive can be a big problem. And when you have a lot of results at once, it can be very overwhelming, especially for a team that is not comfortable with interpreting the results, to say, oh, well, this is a real thing, or no, this is a false positive. I'll just tell the tool to shut up. That's fine, leave it for later. So an important property that you might want out of this tooling to be more effective with the people using it would be being able to limit the findings and go gradually. Idea specific for Snyk, it has flag called severity threshold, so I can say only show me high criticality vulnerabilities. I can say, good, I'll start by just looking at the highest priority vulnerabilities. I'll fix those. I'll get my team comfortable with the concept of the tool, how to react to it, make sure that everyone is aware and can put their hands on it. And then as we are more comfortable, as the build is getting going, we can start looking at the next one in and say, okay, now let's look at the medium vulnerabilities. When we're comfortable with that, go to the next step. Challenges in introducing the tool? Well, I wouldn't say there were really, at least not for Java and React. It was coming with pretty much everything that we needed out of the box. I will actually mention a thing. A test for known vulnerabilities is a test that is not just running against your source code or against your build descriptor file. So the results will be function of that, but it's also function of a form of database state. How these tools work is that they compare your dependencies against a database of known vulnerabilities. In this case, it's important to not only run this test when you change your code base, you introduce a dependency, you update a dependency, but also run this on a timer to make sure that if a vulnerability is found in between the last run and the next future run of your test, you will eventually find it at some cadence. What we did was just have a daily timer to make sure that you will eventually pick up issues. We had way more challenges instead when we tried to use the tool for its Docker support, mostly because for how that's implemented, or at least how it was 1 year ago, I'm not sure if the implementation has changed really. But Snyk needs a local Docker daemon to execute the scan. And as I mentioned earlier, in Concur CI, all tasks are Docker container already. And running Docker inside Docker is not exactly a good experience, nor recommended even by former Docker authors. I've not linked it here, but there's a great article by Jérôme Petazzoni about what are some challenges of running Docker in Docker and why you might want to avoid it for a number of reasons. I won't go into the details here, but if you have the need of making a decision, look up. There is literature out of the internet. But if you can avoid doing that, do. Otherwise, there is stuff ready to use as well. What we had to do in the end was to actually run Docker in Docker, and that was mostly motivated by the potential solutions that we found and our AWS bill. We found out that a way to go around this was to spin up more clusters, open more permissions, lock down some environments. That will have had a certain cost in terms of cluster resources. We're like, well, yeah, we're already spending too much. Let's not do that for now. That's it for Snyk. The next tool that I want to show is FindSecBugs. FindSecBugs is a plugin for spot bugs. It is a static code analyzer. It actually scans Java compiled bytecode, not source code itself. That is interesting. It has the advantage that it can support not only Java, but other JVM-based language that compile down to bytecode. At the same time, though, you need a compiled artifact to scan. That makes it slightly more complicated if you're shipping stuff in a Docker container. Can we fit this nicely in our pipelines? The tool doesn't exit with error with findings on its own, but there's a nice command line flag that we can add to make it do it, so that's fine. And what about findings? There wasn't really an option to filter by severity, but there are options to find by specific categories. Being a plugin for spot bugs, that is a quality control tool, that means that it's basically add a security category of patterns to existing categories of code quality. And if you just want this for looking at security vulnerabilities, you might just say, cool, just give me the security findings, ignore all the code quality. That's someone else is doing that, or some different stage in the pipeline is doing that. Or you can have everything together, up to how your team is comfortable with. And you can filter by only look at my code. Scanning bytecode, it will probably just look at the entire compiled bundled jar that you're shipping that might contain library code, third parties code, or anything else that's not really yours. You can say, yeah, just look at my stuff, ignore the rest. Or you can even say, look at a slice of my stuff. If you feel that there's something that is more risky and you want to configure things in a different way. Other than finding out this configuration things, we had a number of challenges, not particularly complicated, but still. First, like I mentioned, you need to be able to get the bytecode out of your Docker image. For some time, we had the question of, oh, what do we do with that? Because we are compiling in a multi-stage Docker container. That means that it's not like we compile a jar and then we put in a container. We do everything inside the container. All right, what do we do now? Do we change the pipelines to build a jar first, publish it somewhere, retrieve it, complicated? We spent a good day thinking about it. And then it turns out that we just had a case of read the manual. And in Concourse, you can describe a resource to be a Docker image. When you do that, you have the entire file system of it. So we just say, hey, give me the compiled image for this. It just goes, hey, this is the entire file system, including your jar, just there to be used. So it's actually trivial. More interesting was that we kept getting this error out of it, say missing classes for analysis. And we're like, well, I I'm excluding these classes for analysis where you wanted. Long story short, the tool, even if you say don't analyze these classes, wants to know whether they exist or not to analyze your classes if there's a reference. Because of a mechanism in Java dependencies called optional dependencies, of which Spring Framework makes heavy usage of, you will probably encounter this error. It's actually okay. It's just like a consequence of a feature, really. It skews up return calls a bit because it tends to then exit with error even when actually you don't have any finding. There's little tricks that you can do with exit codes to offset that, and then it's fine. We just had to have a little scripty hack, that was it, really. The key point here was really figuring out that it was fine. It wasn't really an error. Lastly, there was some confusion about the results themselves. You get some very cryptic codes like, hey, there's a finding, sec, sp, rf, rm, ul, I can't read this. And there was a lot of confusion of what this is. Turns out it's actually a handy reference to go search in the documentation page. If you go on the online documentation of the tool, there's a one-page page, which can just use the browser search function to copy-paste this, and that will get you to a section in which it tells you, hey, this is this vulnerability, this is a code example of it maybe, this is what you can do about it. And it's great, because even if you don't have a clear understanding of what the vulnerability is from a shorthand description of it, there's a very comprehensive explanation of the meaning, solutions, or mitigations for it. It's really good to get up to speed with the findings. The last tool that I want to present today is related to the problem of credentials leak. This is also something sometimes I would say understated, because when we think about searching vulnerabilities, we look a lot in the code, in the logic. Let's scan some, let's use some static scanners, dynamic scanners, infrastructure scanners. But actually, what about just the team not handling secrets properly and maybe committing them in the repository by accident, or sharing them by email and sending the email to the wrong address? And it's something that it can happen to anyone. It just takes having a very bad day or having slept badly and sending, like picking the autocompletion on Google Mail wrongly. It takes a second, really. And these kind of findings are also being corroborated by the research from Verizon's DBAR. This phrase is from the 2018 report. What they found is like, yeah, use of stolen credentials is still like a very, very huge problem. However, these credentials were stolen. The report didn't really get into where this is coming from, but there is a number of known patterns of credentials leak. One of which is committing secrets into your code base. Very common, I would say, also coming from some tooling to help with this problem is quite recent, like HashiCorp Vault or some practices using AWS SSM. And especially for like test environments, it's just, who cares, it's a test environment, right? Just stick the credentials there in code. But maybe there's more to it. So Git leaks is a tool that provides the ability of scanning your Git repo, and not just the head of it, but the entire history, to find stuff that looks like a secret, credit card numbers. It has a number of patterns of potentially dangerous stuff. And we report its findings to you. Again, some question before, does it fit nicely in a pipeline? Exit with error, yes, that's great. If he finds any secret, it's just errors, and that's fine. But what about red fatigue? That was somehow more of a problem. You can mark commits or patterns as safe, but you can't really limit the findings. And I would say actually for secrets, maybe you don't really want to do that. It's fine to say, okay, we have one big chunk, we have to clean up our repository. Let's do this and make sure that we have a good mitigation, we have a good alternative way to handle these credentials in the future, and everyone's on board with it. The challenges here were mostly about how to handle findings. Do we remove them from the repo? Well, if we add a commit that removes the credential, that will still stay in the history. Do we edit the history? Well, I would strongly recommend against it. at least like having Git being able to keep all the history of everything that going in and editing it creates a number of problems with code distribution, checksums, signatures if you're sending your code, so on and so forth. What you can do is to mark commits as safe via a config file. You can say, okay, I looked at this commit, I cleaned it up. I can say that all the stuff here has been rotated, is not valid anymore, this stuff can stay here safely. If you play catch up from like in chronological order, you can then use an option to say only scan from this point in time onwards. That is handy. Also speeds up stuff slightly. Non-intuitive thing is that doing the whitelisting via config file, this will override the default config file that has the pattern matchers, so you have to re-add them from a copy of the default one. Counterintuitive, but it's quite easy to do. The default config file is available in the code base itself. You just open GitHub and it's there for you. Again, there's not really incremental approach to red fatigue, but I would say that it's fine. Given how dangerous and how fast an attack can be mounted with a stolen credential, you probably prefer to be extra safe with this kind of risks. More interesting challenges were across remediation. That is, okay, I found leaked credentials, I want to rotate this. It's fine if the credentials that have been committed in one code base be used for a single use, but it's often the case that the same credential is used across environments, or maybe, and it's committed in a single place, but then a different team is using the same one, and they know that in your repository there's the real one, or it's being shared over Slack, or there is a number of ways in which credentials can travel across boundaries and not be found. So how we go around this, and what about re-leaking keys that are being rotated? What about the case of we rotate the keys, we're fine, but then our team has not really been educated on the problems that this leads to, and they just do it again? I don't think I have a clear answer to any of the challenges. For sure, setting up learning sessions and educating everyone on the problems, making available alternative solutions is a great way to go around repeating errors. But for the former, what I can say is that it's not only about scanning repositories after credentials already be committed there, but is also using different typologies of similar tooling, something that can be preventative, like Talisman is a tool that can run as a pre-commit hook or a pre-push hook. So you can catch this before the fact. Or maybe there's assurance tooling that can look beyond the scope of your immediate repository. That's it. I would like to draw just a couple of conclusions. First of all, I hope that this convinces you that introducing some security tooling in your pipelines is quite easy. You can do a lot of, with a little work, you can automate a lot of repetitive checks. Red fatigue can be a really big problem, so be mindful of that. Try to see if your tool can help you with it. Tooling doesn't work on its own. It needs people to understand it and adopt it. So make sure to create spaces for learning and sharing. And that's it. Thank you.